Hey Trig folks, welcome to 1.3a Applications in Solving Right Triangles. We're going to continue on next week with 1.3, just doing a few more application problems, but I didn't want to overwhelm you. So I'm going to try to go as close to the book so that you have a guide and also give you the problems that I assigned and show you which example that you should look at to assist you and even draw some diagrams for you in this lesson. Okay, so you're assigned 15, 17, 19, and 23, and I'm going to show you 18 and 21. The first thing with this, I thought I'd jump to solving right triangles. So you're given your triangle right here. Once again, it's that typical triangle, and if you did lesson 1.2, you should have a good understanding on trig ratios. So here is my triangle. This is number 18 I'm going to start with, and I'm given side A, which is opposite angle A, so that's 2, and I know that C is 7. So when you solve a triangle, that just means you have to find all the sides and all the missing angles. Okay, so right now we need to find length B, or you can say it's AC, and we also need to find angle A and angle B. We know that angle C is what, everybody? Yes, you've guessed it, 90 degrees. Okay, so we are going to start with that. Um, I'm going to use Pythagorean theorem. I know that this is my missing side B, so I'm going to say B squared plus 2 squared equals 7 squared. And a little simplifying, we've got 49 minus 4, so that's 45. If I take the square root and I simplify that, that's equivalent to 9 times 5, so B is equivalent to 3 rad 5. So we found our side, okay, so I know that this side is 3 root 5. Now I need to find the angles. So to find, let's say, angle A, what we're going to do is we're going to set up the ratio. I'm going to use, if I put my finger on A, what sides am I given? I'm given angle, or I'm given the length across or opposite angle A, and I'm given the hypotenuse. So I'm going to work with sine because that's so, opposite over hypotenuse. So I know that the sine of A is equal to opposite side 2 over 7. Notice I didn't do cosine because if we hadn't figured out B, cosine, you could, here I'll just write it, or you could use cosine of B of angle A is equal to 3 root 5 because that's the adjacent leg over 7. So either of those will work. So there's a nifty little button in your graphing calculator, the inverse sine, and I'm not going to go into too much detail right now, but the idea of this, because see, we're trying to find the angle. So I want to find the angle here, angle A. And in order to do that, I need to free it up. And in order to do that, I have to apply the inverse. So I'm going to apply the inverse sine. So right here, take this down, and instead, whenever you need to find the angle, think inverse. So sine inverse of 2 over 7 equals A. So essentially what the inverse does is it switches the place of your two functions, your x and y, if you remember inverses and the role of that. So it frees up this A. So now in my calculator, I can go ahead and type that. So it will be, notice that the sine inverse is in yellow, so I need to hit the second button, sine inverse, and I'm going to go 2 divided by 7, close parentheses, and let's see, then I hit enter. Okay, so something seems wrong because I am in like 0.28. That doesn't seem like a very good degree measure. So that makes me think that maybe I need to check my mode. So I'm going to hit the mode button and I'm going to make sure, oh, see I'm in radian. I want to select degrees. So we're going to be in degrees for a little bit. Um, throughout the semester. We'll get to radians eventually, but for right now you want to be in degree mode. So once you hit that, you can quit. Okay, and now I can recall that same entry, and if I hit enter, see how that makes a little more sense? So I'm going to say, okay, that means that angle A is equal to, whoops, we lost it, 16.6 degrees, 16.6 degrees. Now if angle A is equal to 16.6 degrees, that means that angle B is going to be equal to 90 minus 16.6 degrees, which is 73.4 degrees, if I did my math correctly. So now I found angle B. So angle B is equal to 73.4 degrees. Angle A is equal to 16.6 degrees. We found B is equal to 3 rad 5. We already know length A and we know length C, the side of C. So we found all the missing parts of this triangle. That's how you solve a right triangle. Okay, so for 21, what we're going to do is we're given angle B is 26 degrees. We know that little b is 3. So that's all that we have to work with right now. So angle B, put your finger when you draw this on angle B. That's your reference, okay? So what I'm going to do is I'm just going to work with, all I know is I know this angle and I know this side. So that means I need to find A, I need to find C, and I need to find angle A. Okay, angle A is pretty easy because it's just 90 minus 26 degrees, which should be 64 degrees. So we found our angle A. Now we need to find A and C. So let's find A first. So A, what does A involve? And I have my students like, if you think about it, you're dealing with, do it what you know. You know this side in regards to this 26-degree angle in regards to B. And you know this side, right? So opposite over adjacent leg. So we know that the tangent, I'm going to use opposite over adjacent, of B is equal to 3 over A. But we know what B is, so it's the tangent of 26 is equal to 3 over A. Do you see now that this is just an algebraic equation that we need to solve? So if I multiply both sides by A over 1, I have A tan 26 equals 3. Now tan and 26, think of these guys, they're joined at the hip. You cannot separate them, so they stick together. It's just one thing. Tangent is nothing without its degree. So you have 3 over tan 26, and to approximate that, use your calculator. Be sure that you're in degree mode, and we're going to say, let's clear that up, 3 divided by tan 26, close my parentheses. So that is approximately 6.15. So here we go, 6.15. Okay, so we've got our length A. Now we can use Pythagorean theorem to find C, or we can use angles again. I actually think it's more accurate. So does everybody see one way to do it is you could do 6.15 plus 3 squared, that's squared to equal C squared and solve, or, so this is one way, or you can use ratios again, and I think I prefer that. I think it's more accurate because see, we're rounding 6.15 already. So let's go with, we've got our reference angle is B. I'm dealing with the opposite side now in regards to the angle B. So it's opposite leg over hypotenuse. So it's the sine. So sine of 26 is equal to opposite leg, which is 3 over C. Now, one little quick algebra, and you guys are going to have to do a lot of algebra in this class. So what I would recommend, and I'm going to change colors, is just if you bring C and you want to bring it over to the other side, it goes to the opposite. So it's going to the top, and this sine over 26 is going down to the bottom if I bring it over to the other side. So now C goes up to the top on the left-hand side, 3 remains there because I haven't moved it, and sine 26 goes down below. So that is your little quick algebra lesson. It's just a shortcut. So we're going to do 3 divided by sine 26. And that's approximately 6.84. So let's say that is approximately 6.84. Okay, make sure there aren't any units. We're going to get into some applications where you will need units, but they don't give us any, so we don't need to say it. Let's just check our work with this Pythagorean theorem. So let that be a little extension. See if you get the same answer by solving for C in this. So I'm not going to lie, these application problems aren't easy. So I thought that I would walk you through the example and explain the example. Then I'm going to show you the problem that you're assigned and help you set up the diagram, and then we'll go from there. So the first example, 112, has a person standing 400 feet away. So let me just walk you through the diagram. 400 feet away from the base of a mountain. So that's what this 400 feet represents. So then you have the angle of elevation is 25 degrees. So that's what this angle of elevation is right here. Angle of elevation is the rise from the horizon up to whatever it is that you're looking at. Then that person walks 500 feet straight back, so that's what this distance from here to here is. And the new angle of elevation is 20 degrees, so that's this. They want us to calculate the height of the mountain, so we need to find h. Okay, so this is the unknown distance basically from the center of the mountain out to the edge of the mountain, which is kind of hard to calculate, right? But we can actually solve this with the information given, finding 2 points using 2 survey points. So here we go. I'm going to draw the 2 triangles that we have. The first triangle from when we're 400 feet from the mountain, here's h. And this length is 400 plus x. So this height right here is 25 degrees. Okay, so they use tangent because they're dealing with an opposite leg and an adjacent leg. Okay, so for the first equation, they say that the tangent of 25 degrees is equal to h over 400 plus x. Okay, so that's in triangle, the right triangle 1. See how convenient it is to make right triangles. So the next triangle I'm going to draw is the one where the observer walks farther away, and so the angle of elevation is less, but he's a farther distance away. So the angle of elevation is 20 degrees now. The height is still h. This is still a right triangle. Now we have 500 plus 400 is 900 plus x. So that's that length. I'm still dealing with the tangent. So now I say, okay, the tangent of 20 degrees is equal to h over 900 plus x. Notice that we have 2 variables, so right now it's hard to do much, but we can set, if we solve for h in both of these equations, we can set the equations equal to each other. So from this equation, from equation 1, we have that h is equal to tangent of 25 quantity 400 plus x. I just brought that 400 plus x, multiplied both sides by 400 plus x. Cancels out on the bottom on the right. Now it's on the left, okay? And then on the other equation, we've got that h is equal to tangent of 20 times quantity 900 plus x. So they leave out a little algebra, which I'm going to walk you through in this. First of all, this is where we were at. So we're here. Next, they distribute, which they don't show you, which I'm going to do here. So you have, if you distribute the tangent of 25 to both of these, you have x tan 25 plus 400 tan 25 equals x tan 20 plus 900 tan 20. Next, what you do when you're solving an equation for x, you want to get everything with x onto one side. So see, I'm going to bring this over to this side and this over to that side. So now we have x tan 25 plus x tan 20. Excuse me, not plus, it's a minus because I brought it over to the other side, right? So let me erase that. So there's a minus there. And that equals, now I have 900 tan 20. And now since I'm bringing this 400 tan over to the other side, it's minus 400 tangent 25. Okay, so the trick with this, and this is always one of the hardest algebra problems for students, is to factor out that x. So now you have tan 25 minus tan, I forgot that 20, equals all of this, right? I'm just going to do ditto. And so now you can see if you bring this over down below to the other side, you're left with this equation, which I'm not going to write it out, but that's what you get. So if you need help with entering this into your calculator, you know what, I'm just going to do it real quick to show you. What I recommend when you do these long problems, it's more accurate if you do it all at once. So I'm going to do parentheses, and then I'm going to do 900, and make sure you're in degree mode again. That's the mode button right here. So it's 900 tangent of 20, close those parentheses up for the tangent, then it's minus 400 tangent 25, close parentheses for the entire top, divided by, now do parentheses below, you have tangent of 25 minus tangent of 20, close parentheses for the bottom. Drum roll, please. Here we go. All right, so we got that answer, 1,378 feet. Now that's the height of the mountain. Okay, so when you do these and when you write your assignment out, please answer it in a some kind of nice sentence. So to give like the height of the mountain is this. Oh, actually, no, that's just x, right? So we actually haven't found the height of the mountain. We just found x, remember? So the last step is to substitute it into this formula. So you can substitute it into either one. So if looks like they did the first problem right here and they plugged in x. So that's where they get the 13,000 or 1378 and plus 400 times tangent of 25, and that would give you 829 feet as the height of the mountain. Okay? So one of your problems is to work on number 3, and it says as the angle of elevation from the top of a tower to the sun decreases from 64 to 49 degrees during the day. So that means that this whole entire angle from the top of the tower, which is right here, angle of elevation from this horizon point up to the sun, so here's the sun at this point, is 64 degrees. Through basically parallel lines and this transversal, this is also 64 degrees, okay, this angle right here. So that's really important to note. Then it decreases to 49 degrees. So once again, here is, if you extend this line, these are parallel lines. And here's a transversal that's cutting through it. So this this line right here is parallel to this line, the ground basically, which we're assuming is flat and level. So this is 49 degrees as well. Okay. Now note that you have a right triangle because we're assuming that the height of the tower is perpendicular. We're not dealing with the Leaning Tower of Pisa. And so the hardest part I found in this was the wording. It increases 92 feet along the ground. So we start here, this shadow, but then the shadow ends up, as the day progresses, 92 feet beyond this, okay? So here is your other unknown. You have y here. Okay, so that's your diagram to help you answer number 3. Remember that we have the Q&A forum, so I'm okay with you guys posting. If you find a value and you want to check with classmates to see if it's correct, go ahead and put it up there because I still need to see your work on the assignment, so I know that you're doing all of the correct work. So please feel free to discuss these amongst yourselves and compare and see if you guys are getting the correct answers. We're trying to find x, and this is very similar to the example I just showed you to 1, 1, 2. Okay, so I'm going to let you try to do that, but I wanted to get it set up for you. So I wanted to explain 115 as well. It talks about in astronomy, we'll find the distance from the Earth to the Sun, and we're going to use this idea that A is a point right here, and basically BA is tangent to the Earth, meaning that it's just touching at one spot, okay? If we're given this angle right here, alpha, which is the equatorial parallax, so it's given to be 0.00244 degrees, which is a very small angle, right? So if we know that, and we're assuming that the distance from the center of the Earth to to this point A, because it's the radius is 3,956.6, we can calculate this distance OB right here because we have this angle, alpha, and in regards to alpha, I have an opposite leg and I want to find the hypotenuse. So I'm going to call that OB. So we have the sine of alpha, which is 0.00244, equals 3,956.6 over OB. Now, once again, to switch this around, I want to bring this OB up to the top on this side. So this is the distance from the center of the Earth to the Sun, and I'm going to bring this guy down below on that. So honestly, you could show the work that you're multiplying both sides, or you could just, it's almost easier to just visualize this like that. So anytime you move something from one side to the other with a fraction, it goes down below. So that is the calculation, and if we calculate it according to this up above, you end up with 93 million. So we could figure that out. Yeah, so they rounded to 93 million miles. That's the distance from the center of the Earth to the Sun. One thing I wanted to talk about, and there's a supplemental lesson I want you guys to watch in week 2, and you'll see it, is the idea of degree, minute, seconds. So that's a tiny, tiny angle, isn't it? So if we wanted to convert that to degree, minute, seconds, because it might make more sense, let me show you how to do that. And this video online on YouTube shows you as well, but I'm typing in what alpha is equal to, 0.00244. Then I hit second and I select the apps button, which is the angle, and I want to convert that to degree, minute, seconds. If I hit enter and then enter, that tells me that we have basically 8.784 seconds, okay? So follow the example I just did for number 6, okay? And the only other thing I want to show you that because they give us that this is 57 minutes, okay? So if you wanted to calculate that and convert it into degrees, once again, the only thing I want to show you is that you'll arrive at an error. That's what my calculator kept doing. So I want to show that this is 0 degrees, so I hit the angle button and I select degrees. Okay, then it's 57 minutes, so I'm going to select the angle button again, and see it's number 2. Okay, for the minute button, let me just show you. Excuse me, the seconds. It's 0 seconds. You don't have to enter this, but I just wanted to point out that it's alpha, and see the quotation right there. All right, so if you want that into degrees, you just hit enter, and it says it's 0.95 degrees. So we can say then that 57 minutes is equivalent to 0.95 degrees, and you can use this angle in your calculations. So example 116, this is the last example that we're going to do today, is that an observer on Earth measures an angle, and it's 32 minutes 4 seconds from one visible edge of the sun to the opposite other edge. So here is the observer on Earth. This is the angle that it creates, 32 minutes 4 seconds, and this, we're looking at the sun in this case. I think you guys are going to look at the moon in your problem that you have to do. So they're saying let E be the Earth and S be the center of the sun. So the observer's lines of sight to the visible edges of the sun are tangent lines. So once again, a tangent is just touching the surface of the circle here and here. and the points are A and B. So we know then that angle EAS, so that's angle EAS, this is, believe it or not, a 90-degree angle, and this is a 90-degree angle. So what I would do when you draw these pictures, if you're getting confused on looking at just the whole diagram, you can take it away, and we're just going to look at the upper half of this triangle. So as they do right here, they take half, and you can actually do that with degree, minutes, seconds. Take half of 32 and 4, and you get 16 and 2. So we know that this angle is 16 minutes, 2 seconds. Okay, and so we also are given that that the distance, what did they say? So the distance from the last problem, and you guys have to use that for the moon as well, is 92,000 or 92,908,394 miles. And but we were treating it from the center of the Earth. So what this length is this is 92,908,394 minus 3,956. So be sure to do that when you do your problem as well. So this side right here, this length is 92,000, wait, 92,904,437.4 miles. Okay, so now we need to find the distance. They're asking us to estimate the radius from the center of the sun out. Okay, so does everybody see that this is the radius here? So we want to find r. And in order to do that, I am given this angle right here. And this, even though it's hard to see, if you get confused on what sides and what parts you're given, always go back to the right angle. Where's the right angle in this triangle? It is right at the top here because that's the tangent line here. Okay, so the opposite, I'm given the hypotenuse. This length is the hypotenuse, that really big number. I'm also given this angle. So, and I'm given the opposite leg, that's r. In regards to this right triangle, these are the legs, and I'm given the opposite leg with respect to this angle and the hypotenuse. So that's so opposite over hypotenuse is sine. Sine of 16 minutes 2 seconds is equal to r over that really big number. No, okay, I guess I'll put it. So it's 92,904,437.4. So what they do is they bring this up over to the top here. 92,904,437.4 sine of 16 minutes 2 seconds. We're going to calculate that because I want to show you that you can calculate that using your calculator. So I'm going to, just to save time, I'm just going to show you how to do the sine of 16.2. So we're going to do not 16.2, 16 minutes. So you type in your 0 degrees and you hit the second and the apps button, which is the degree. So 0 degrees, and we've got 16 minutes and 2. We're going to use the alpha button here. Close, and that will give you that sine, and then you multiply that times this huge number right here and to get to final answer. So this problem is very similar to the last one that we just did. It's finding the radius of the moon. We just found the radius of the sun. So set it up accordingly. You have 31 minutes and 7 seconds. You can convert that to a degree. Remember, you're only using half of that. So once again, please post on the question and answer forum. Come see me during my office hours if you have any questions. Send me an email, and I also have the Blackboard instant messenger too. So if you need to get in touch with me, that might be a way as well as CCC Convert. Just if you're going to do CCC Convert and want to get in touch and do some math on there, please just either notify me if I'm on IM, let me know, or give me a call in my office, 588-5212, and I'll log on if I haven't already. Okay, good luck, everybody.